they're supportive and they're essential, right? They're essential for our day-to-day tasks. Similarly, utility software are needed for the operation of the computer. That does useful job for the user, not essential to the operating system, not the reason user using a computer in the first place. It's not application software. This is a bit confusing, right? Not essential to the operating system. I think that what they're trying to do say is that uh, even without utilities, operating system can work. Like operating system is not dependent on utilities. I think that's what they try to mean here, right? But utilities, they actually do a great job assisting the operating system. Not the reason for using a computer in the first place. Yeah, utilities are supportive tools, so they are not used for performing our day-to-day tasks. For that, we have application software. So, what are the examples of utilities? We have basic tools like text editors, Notepad, right? Calculators, command prompt, text editor, software accessibility, right? Just a minute. Right. They're usually included as part of the operating system, right? So some of the utilities, they're bundled with the operating system. When you install the operating system, they come ready. What do you call bundled with the operating system? They're also installed automatically. Then you have file management tools. No matter how much storage you have, how you always manage to fill up the space with files. This brings problems such as not being able to find your favorite photos, losing files if there is a fault, and things simply running slow in your computer. So file management tools like backup program, right? If your drive is running out of space, the backup program will automatically kicks in and ask you to move some of the files back up to your files, and you can set automatic backups and so on. Copy your files to another location. Some programs can recover files, recovery tools, which have been deleted, or repair files. Right, disk repair. Have you seen, like, most of the time this disk repair program runs if something happens with the hard disk. Disk
Yes, sir.
Yeah. So that's a file management tool. That's a utility, right? So some of the utilities are bundled with the operating system, and some of the utilities we can install as third-party tools, right? Now backup. What is a backup? Backup is a copy. It's a copy of the original files kept in a safe place, right? So what's the purpose? What's the advantage? If something happens to the original, we can use the backup to restore, right? That term is called restore the files. There's another term that goes with backup, but it's different to the backup. It is called archive. Archive, right? Right. Archive is the original files. These are the original files kept in a safe location. So if the archive is lost, you lose the originals, but they're kept safe in a separate environment, separate area. But backup is a copy. It's a copy, right? It's a copy. Okay. Let me share the screenshot. You highlight the book and write these things. Another useful file management tool is for converting files between different formats. File converters, especially multimedia files like audio files, MP3 to wave to MP3, right? Uh, Movie files, converting movie files, even photos, right? Converters, file converters. Another important file management tool is defragmenter. Right now, you know what defragmenter is. You have learned this for IT. Defragmenter. Defragment is needed because of fragmentation. What is fragmentation? Fragmentation is, uh, you know, pieces, right? Pieces of files, right? They are scattered all over in the hard drive, in the secondary storage. So when the pieces of files are scattered, what happens? Then we need to bring these pieces together from different locations. This will take time. So the performance will go down, right? So let's say if this is the hard drive, a portion of the memory, secondary storage, we have part of the file here, right? The other part is here of the same file, another one here. So we have to bring these pieces or the scattered files from different places. But there are empty spaces in between because some of the file, you know, fragments that were here are already gone, deleted. So there's empty space. So when you run the defragmenter, what happens is it will look at the space availability and bring these scattered files into contiguous memory locations, nearby memory locations. So now you will have something like this. You will have these three parts in nearby memory locations. Now the space is utilized. At the same time, you can bring the file pretty fast. And as a result, the performance will be improved. Performance in the sense, read-write speeds will be improved. This is especially applicable to magnetic hard drives, right? Magnetic hard drives like the hard disk drive. Why? Because magnetic hard drive is quite slow because it has moving parts. With the SSD, defragmentation is not really needed because it's anyway 100 times faster than hard disk drive. Okay, right. Another important file management tool is the defragmenter, which is used to speed up access to data stored. Right now, in order to perform defragmentation, you need to use the hard drive for a certain time because you need to allow the fragmentation. If you haven't used the hard drive, and if your hard drive is like 90% free, then there's no use of defragmentation. Right? If the files are scattered, only defragmentation will be helpful. Files are not stored on the disk in one large chunk. They are stored in smaller pieces called sectors or clusters. In a single file cluster can spread across the disk. Accessing these fragmented files can be slow. So a defragmenter moves these files around and bring them closer, right? Speeding up the disk access. Unlike magnetic disk drives, solid-state flash drives do not require, do not require defragmentation. Does that mean you can't do defragmentation? No, you can, but it is not going to improve the performance in a big deal, as access times are same across the entire volume. You can also use file management tools to compress files. Okay, here's another utility, compression tools like WinRAR, WinZip. This frees up space on the disk, but those compressed files are then slower to access as they have to be uncompressed. Right? When you compress the files, yes, you have more free space, but accessing the compressed files can be time consuming. Why? Because compressed files can't be accessed directly from the application. Right? If the compressed files are Word files, you can't open the compressed file in Word straight away. They have to be uncompressed. So that can take time. But advantage is it saves space. Okay, then security tools. Security tools. These are also utilities like antivirus, anti-spyware, Computer viruses and spyware can be used to capture private information, introduce a process on your computer to do a job for the attacker, such as send out spam mails to crash an important machine, such as a web server, right? Some are simply written to annoy users. This software is called virus because it copies itself. Virus. The main feature of virus is that it replicates, just like biological viruses. They replicate. Even the worm replicates. They replicates and then spreads. Virus spreads by attaching, just like the biological virus. They attach to our body. So these attach to the files, executable files like exe files, bat files, or batch files. They want a trigger to uh, trigger when executing. They want a trigger to activate. Worms, on the other hand, are not so disastrous like viruses, but they also copy themselves and they spread by moving from place to place. That's why they are called worms. They move from one computer to another in the network. And their job is to use resources, overuse resources. Right now, remember we looked at CPU resource and the RAM usage. So these worms can overuse the CPU time, overuse the RAM allocation. As a result, the computer becomes really slow, right? And for your information, there was a worm attack some years back in our lab file. If today several computers were slow in the sense like you can't log in even, like you don't see the login screen even. It takes ages to see the desktop. And tomorrow it would have spread to other computers. So ultimately, I think we have to format all the machines, right? Antivirus tools try to identify the code that copies itself and prevent those processes from running. So, antivirus, they have this virus definition database, right, with the details of this malware. So they can identify these and take actions like deleting, quarantine, right? They can stop spreading them, right? Okay, so the words that we learned, defragmented. It's a utility. What does it do? It brings all the scattered files, not everything. It brings most of the scattered files to nearby memory spaces. As a result, the files can be accessed faster and the read-write speeds can be improved. This is mainly applicable for magnetic hard drives, which has a lot of moving parts. Virus is a malicious program that can cause damage to hardware and software, and it replicates itself and distributes, gets attached to executable files, and yeah, and they can be really disastrous. Okay, right, and then spyware, a software that will stay quietly in your computer, recording your details and sending them to unauthorized users. Then firewall, firewall, right? Can anyone tell me what is a firewall? You have learned this for IT. What is a firewall? If they ask what is a firewall, what do you say? Anyone?
So
Firewall?
it's a security device for a network that would control which sites would be allowed for viewing and which wouldn't.
Okay, very good. Yes. Firewall is a software and hardware combination. Okay. It's a software and hardware combination. You can think of firewall as a wall around your house, and it mainly blocks unauthorized access from the internet to our local network, right? And also it can monitor the data going out from our network to the WAN. Mainly, it blocks unauthorized access. And how does it do? It is based on some rules that is set, right? These rules are called inbound rules and outbound rules. So based on that, it will monitor and block unauthorized access and threats into our network. It's a hardware software combination. You will have software firewalls like Windows firewall, which is Defender. You have hardware software firewalls, which is built into the router, and you have completely hardware firewalls, which can have more protection, especially for an organization. Firewall software controls your connection to a network, deciding which network data can flow to and from your computer, right? Why would you build a wall around your house? Is it to block the people inside the house going out? Not really, right? You want to block the people coming in. So you put a gate and then you put a security guard or a camera to monitor what's going on. So it blocks, at the same time it monitors, right? It not only monitors people coming in, even the household members going out. So your parents can see you when you're going out of the house. Something like that. Okay. So more firewalls, more protection. More firewalls, there will be more protection. Okay. So security tools like these are also utilities. Right. So we looked at so many examples of utilities. What are they? We had simple text editors to file management tools such as defragmenter, backup program, right? Disk management, which can be used to partition the hard drive, and also security tools like antivirus, anti-spyware. Okay, that's it. And then simulation and modeling. They're talking about simulation and modeling a little bit here. Okay, so let's look at this also. Right, simulation and modeling. Now, model is something that we uh, use to recreate a real world scenario, right? The model, even the models like human models, what do they do? They represent something, right? These like those models in these what do you call catwalk? What do they do? They model something. They represent something. So here also model means you are representing a real world scenario. These models can be in two forms. One type of models deal with numbers, functions, formulae, right? Number crunching. And they try to predict something using numbers, graphs, charts, and etc. Then you have another type of modeling, which is using VR, virtual reality. And that is trying to recreate a real world environment like using real world like objects like weather forecasting, flight simulation, that type of modeling. So whatever it is, model is used to recreate a real world scenario in the computer, and then we put the model into test. By testing the model, we can learn a lot of things that will be very important, very essential uh, to run the same thing in the real world, run the same scenario in the real world. Okay. Um, so when you're studying, also you talk to yourself like this. You question yourself, you talk to yourself, you get into a discussion with yourself, right? Rather than trying to read and by heart each and every line here. Okay. Um, you learned about how you can use abstraction to model real world. So now recall your memory. Abstraction was removing unwanted details from a problem. When there's a high level of abstraction, we don't need to worry about the underlying functions. Right? It makes it easy for us to use. It makes it more user friendly, and it reduces the development time. By now, you will be getting used to the idea of abstraction as a central part of computer science, right? So higher the abstraction, it will be easy to solve the problems. It means hiding complexity, only exposing the key features of a situation and leaving out the details. So in the future, these technologies are going to have a lot of abstraction, which means it's going to make it easy for the developers, right? And then you will have to concentrate on how to apply, how to make use of the technologies. You don't really need to learn how it works, right? You will have to learn how to use it. Computer science allows us to do experiments that can't or shouldn't be done in the real world. So this is an area where you will be heading to after learning computer science. You might be heading to this side, this area in computer science, modeling, simulation. You can't increase the average temperature, right? Experiment that shouldn't be done in the real. You can't increase the average temperature of the earth to see what happens to our weather. You shouldn't stop one of a pair of twins from exercising to see if it causes depression. What? You shouldn't stop one of a pair of twins from exercising to see if it causes depression. Okay. You can, however, write a computer program to model or simulate these situations, right? So model means creating the prototype. Simulating means you are putting it into work, you run it to see the results and see what results you get. Scientists, engineers, economists, even economists, right? And other experts can ask, what if, right? Now, economics will be using mathematical models, which I told you, like using functions, formulae, right? Scientists and engineers will be using more of virtual reality. Whatever the modeling simulation is, you'll be asking what if questions. What are these what if questions? Running a computer model with a given set of inputs to see what the outputs are going to be, right? And then based on that, you can predict what will happen if I give this value, what will be the outcome, right? Economists, okay, what will happen if we tax this amount? If our tax amount is this, what is the impact it's going to have on the people? And then you put it into a chart. What if? Okay, to get this amount of profit, what is the minimum price we have to sell this at? What if? Right? Using computer models. For example, if a bridge, what if the bridge were twice as long? Can we do that in the real world? No. But we can do it in the computer. But then there'll be problems also, right? There'll be some questions. Okay, can the computer recreate the real world scenario completely? No. Right? In the real world, there can be several other factors affecting, so many other factors affecting, right? And the modeling, the simulation may not be able to recreate everything, but at least it'll save our time. It'll be safer than putting everyone in danger. It'll be cost effective. So many advantages are there. There are two big problems with this approach. The model simulation includes assumptions. It's not the reality. So the answers might not be right. So what you have to do, you'll have to run the simulation again and again, especially when you are inputting details, you will have to get the right details. You might have to take input several times and then average them and then input them to the simulation, right? The real world is far too complicated to allow every possible factor in your model. So you have to use abstraction to simplify it. This makes it even less likely that you will get completely right answer. Right? What does that mean? The real world is so far complicated, far too complicated to allow every possible factor in your model. So use abstraction. When you use abstraction, what do? You remove certain things. You remove unwanted, or you focus on the most important sections. You leave out unnecessary details. When you leave out unnecessary details, what will happen? Right. Okay. So when you try to use abstraction, now here's a point where abstraction may not really work well, right? Because it says so you have to use abstraction to simplify it. This makes it even less likely that you will get a completely right answer, right? In a modeling situation, when you use more abstraction, what will happen? You will leave out more details, whereas we have to look at more details, right? If we want to match the modeling to the real world, we have to look into more details. But if you use abstraction, what will happen? We leave out details, and that is not going to give you a correct result on the real world scenario. That's what it means, right? Okay. Okay, here are few examples. Here are some examples of computer modeling. Okay, what are they? Examples of computer models. A flight simulator allows pilots to train fly aircraft safely. They can make mistakes in the simulator without endangering their own lives or lives of other passengers. Commercial flight simulators use movable cabin and real flight controls so pilots can see, hear, feel just as they were flying a real aircraft. If you were to watch the weather forecast, you will sometimes hear the presenter talking about their computer and sometimes about computer models, the atmospheric models used to forecast the weather are some of the most complex pieces of software that exist. Because these models, they take sensor readings all around the world, and all these details are put into the system to predict the weather. Right? I mean, look at those weather forecasting. They predict for like at least a week ahead, right? And most of these weather forecasting are, I mean, so accurate, right? Not the Sri Lankan weather forecast, right? They split the atmosphere up into small pieces and up and keep track of the temperature, pressure, humidity. Now these sensors are everywhere, and they connect to the internet and they send the details, data they are collected, gathered in a place. So there are like, distributed systems running, right? There's a lot of AI into it in each piece. They start the model with real measurements and they let it calculate the effect each piece the atmosphere has on its neighbors and see how weather patterns develop. Another example of computer model is used for earthquake prediction. Unlike previous examples, we don't know the mathematics behind how earthquakes work. Models like these have to use information from the past examples. Uh, like, the earthquakes, um, like the one which caused tsunami. When they look at these patterns, uh, the activities, right, the systems are able to predict when the next major earthquake is going to happen and the areas where they are going to happen. I think in Japan there's a sophisticated system, right? That's why, um, I mean, I think they developed the system more effectively after the 2004 tsunami. 2004 tsunami, there was no such method of predicting, and so many lives were lost. More than, I mean, close to 3 lakh people. But after a few years, there was a huge tsunami in Japan, and amazingly, only few deaths were reported because of their early warning systems. But the damage was unbelievable. But the human loss was really less, right? To come up with the best guesses as to what might happen and when. Some common techniques used in such models are heuristics, Monte Carlo, and neural networks. There is a whole field of computer science devoted to finding patterns in data and using them to predict the future. This is called machine learning. Machine learning. You train the computer program to look at the patterns and learn from it, and then update its knowledge base, right? So gone are the days where we used to say like computer. Remember when you were small, you said the computer is dumb. It cannot think, right? We had to provide instructions. Now, fast forward to today, um, computer has become almost like the human. It's now ready to beat the human because we have AI. AI is also gone now. We have machine learning. We have deep learning, neural networks. It's so advanced. Right now, only barrier between the humans and the computers is that computers still can't visualize new things, new concepts. When that is sorted out, there won't be any difference. Or, I mean, there will be a difference in the sense computers will be better than humans. So, what are the models? Heuristic, a type of algorithm capable of finding a solution, a problem easily, quickly and easily. But how? Trial and error, trial and error. An educated guesswork to cut corners and remove less likely alternatives. Heuristic algorithms don't always find the best solution, but they will usually find the one that works. Right? We try. I mean, day-to-day work. I mean, day-to-day lives. Also, we do this, right? We use this model. We try things and we check the output, and based on that, we learn something. We do trial and error. Like take a small kid. That's what he does, right? He's using a heuristic model. He try things and then he learns. Trial and error. But when something works out, they think, okay, this is the solution, but that may not be the best solution. But the solution is there. Trial and error. Monte Carlo. Monte Carlo. Um, Carrying out a statistical analysis of a number of random samples to get approximate solutions to a problem. The larger the number of samples, use more accurate. Okay, that's what we do in science, right? We run the test several times, uh, different times, and then we take the readings We take the average of the readings. Why do we do that? To get a more accurate result, accurate prediction, right? So this method relies on the figures, right? Number of times you do the, uh, you know, test run, and number of samples you used, and trying to increase the accuracy. In this one, it's just trial and error. If something works out, you use it, but that may not be the best solution. Neural networks process information in a similar way to human brains and learn and adapt over time, right? Just like we have the brain, the CPU, and then we have the neuron system flying into all the parts of the body, sending signals, right? And using use of sensors, taking decisions, right? We try to mimic the human neural system using computers, right? This makes them useful tools for recognizing faces, face recognition, identifying illnesses by looking at the symptoms. They can accurately detect the illness, and quality control of products. Computers are normally not very good at these things. Computers are not normally good at these things, but now it's changing. It's changing, right? So neural networks, they rely on artificial intelligence, machine learning, and it helps to make better decision making, to do better decision making, and sensitive decision making, complex decision making than these two, right? Even in the second method, like when we take number of samples, we don't know how accurate the sample taking is, right? But and these two are normally done by humans. But when it comes to neural networks, it's the computer. If the computer is programmed in such a way, it'll make accurate decisions as much as possible. Okay. So machine learning is a branch of AI where the computer is able to update its knowledge base, just like a child learns from mistakes, and then he will not do that mistake again. The computer will learn like a child and update its knowledge base on its own. Right? Previously, we had to do it. We had to tell the computer, okay, avoid this, take this path. But now the computer is able to judge, decide, and update its own knowledge base. That's where we are right now. Okay, right. I think that's the end. Do you have any questions? Anything to share? So one day you can be a scientist, computer scientist working on neural networks, develop an interest. Right? How about you are a research computer scientist, you research on neural networks, you are a machine learning expert one day. So imagine these are the branches in computer science, right? Okay. Right. So I'll give this checkpoint questions for homework, and then we'll discuss that in the next class. And we are done. We're done with software. We need to do hardware up to virtual memory and few practical components. Let me take 10 minutes from your time and quickly move to one of those practical components, right? Let me see the checklist. Strings we finished, no? Strings we finished. Input output. Just 2 pages. We'll take that now. Input output part 1, 70 to 72. Okay, can you turn to 70, page 70? Page 70. Input output. I think it's a very, we're supposed to do only up to 72. Because after that, it's text file handling, which is for the next term, right? Okay, let's do this quickly. Okay, so stay for another 10 minutes. Input output, right? Right. So in a computer system, like even the models, it's all about inputting details and outputting the information. In that simulation and modeling example, we input data and we output. So when you are inputting data in that modeling example, we needed to make it accurate as much as possible. So how do you make the data input accurate? By a process called validation. And what is validation? Validation is checking whether the data can be accepted or not, whether what we enter is accepted or not. You must have learned something called garbage in and garbage out when you were small, right? So that means if you enter garbage into the computer, what you get is also garbage. So you have to make sure that you check the data that you enter. How do you check the data that you enter? Through a process called validation. But remember, validation doesn't check whether the data is correct. Validation can't guarantee that the data entered is correct. Why? For example, if the field is date of birth, we can enter a date as long as we enter it in the correct format. But if it is the date of birth, how do you ensure that it is the correct date of birth of that person? You can't. As long as it's a date, it is accepted. So, validation can't check whether the data is accurate or not. It checks whether the data can be accepted, whether the data is reasonable or not. Okay. So, what are the validation check techniques that we have? This you have learned for IT as well, for database. Range check. What does it mean? It checks whether a data lies between two boundaries. What are the two boundaries? The lower boundary and the upper boundary. Let's take this example. Boolean valid. Set valid num to false. While valid num equals false. That means as long as valid num equals false. If you want me to explain again, let me know. Send, please enter a number between 1 and 10 to display. Receive num from integer keyboard. You ask the user to enter a number. If number is greater than 1 and number is less than or equal to 10, equal to 1 and equal, greater than or equal to 1 and less than or equal to 10, set valid number to true. End if, end while. Send, after exiting the while loop, send, you have entered ampersand. What is this ampersand? What is this ampersand, Naila? What does it do? Rushda? Shohami, Tiloshana? What is this ampersand? What does it represent?
Sir, is it just to represent the AND command?
Yeah, it is and, but what does it do? It's not the logical and. It's not logical and. What does it do? This one. Didn't
So
you
it references to the correct field.
no? Didn't you learn this? Ampersand. This is concatenate, right? Concatenate or join. Concatenate or join. join. Okay, concatenate. That's in pseudocode. In Python, this is plus. And also you should remember that concatenation is done only on strings, right? So if there's a number, it has to be converted into a string. But here, number is an integer. You are joining the integer using with a string. They're not really converting this into a string, but that's all right because this is pseudocode. Right? Otherwise, they should have written it like this: str number. This will convert the number into string and then concatenate. But ampersand in pseudocode is concatenate. In Python, it's plus. And remember, concatenate is done on strings. So if there's a number, it has to be converted into string. Okay, so what does this do, this code? There's a Boolean flag value, which is valid. And you set the valid. Okay, there's a mistake here. What's the mistake? This valid has to be valid num. This valid should be valid num. You define a valid num variable called, valid num as Boolean, and you set it to false. As long as valid num is false, that's true, right? Because we have set the valid num to false. As long as it is false, ask the user to enter a number between 1 and 10. If the number is between 1 and 10, you set the valid number to true. Now, when it goes back and checks the condition, the while loop will run as long as valid number is false, but now it is set to true. If it is between 1 and 10, what will happen? It will exit the while loop and output this. Got it? Understood? Yeah, any question? No? Okay, shall we quickly code that and see? If you can do it with me, do it. This is range check, okay? Right. First, watch how I do this. Right? Boolean valid, set valid num to false. So valid num to false. As long as, while means as long as valid num equals, it should be double equal, right? Because you are doing a check. In pseudocode, this is single equal, even if it is a check. And here it should be double equal. Valid num equals false. Please enter number between 1 and 10. And you have to read that as number. So these two can be combined. Number equals int input. Please enter a number between 1 and 10. Okay. Receive number, that's fine. If the number is greater than or equal to 1 and less than or equal to 10, set valid number to true. If number is greater than or equal to 1 and number. Now remember, you have to put this number again, nah? Just like that. Otherwise, it's wrong, right? You need to repeat the variable name. Number is less than or equal to 10. What do you do? Valid num is set to true. That's it. When it exits the while loop, your output, you have entered number to display. Print. You have entered. Okay, now concatenation. See this. Plus number. Okay, now I'm not converting it to a string, right? See what happens. See what happens? There you go. What does it say? You can only concatenate strings, not int. So what do you have to do? You have to put str bracket and bracket, because str is a function. Now the number will be converted to string and joined with this. Okay, right. So I'm going to share the screenshot. So you have to do it. You have to do it separately after the class, right? Maybe tomorrow, right? You do it and share the screenshot in the group. Then I know that you did it correctly. Okay. So I'm not going to let you do it now because I need to show the other two quickly. So here's the code. You type it and share it. Okay, the next one, brain check. Next one is presence check. What is presence check? Presence check is checking whether a data has been entered or not. Presence check. In database, of course, presence check was there with primary key. It has to be entered. Set username to blank while username is blank. As long as username is blank, receive username from string keyboard. So as long as username is empty, you ask the user to enter it again and again. So when he enters something, it will exit the while loop and output with hello username. Simple. Let's do it. Okay. Username. Now this is person check. Username equals blank. While username equals blank. As long as, when you're typing, you talk to yourself. As long as username equals double equal, huh? Don't forget blank. What do you do? Receive username from string. So username equals, should we use int? No, just input. Enter. Yeah, they should have output something, no? Enter your username before receiving. Enter username. I hope you are not sleeping. Okay. So when he enters something to this, it will exit the while loop. As long as it's blank, it will continue. When he enters something, it will exit. And then we output with hello. Right? Hello. Plus, again, plus is concatenation. Right. This time, do we need str? Do we need str on username?
No, we don't, sir, because it's already
Yes.
in text form.
Yes, because it's already in text, so you don't need username. That's all. Okay. Right. Let's see. Username. I'm not going to enter anything. Blank, 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 blank. When I enter something, exits. That's process check. Okay. Easy, right? Okay, so make sure that you do this and share the screenshots, right? Okay, next one is lookup check. Lookup check. Lookup check. What is lookup check? In database also we have lookup check. There is a set of values given. When you enter value, we check whether that is there in the list. Okay. A lookup check is used to test a value is one of the predefined set. They have already given the set of values. So we check whether that value is there in that. The list is acceptable values can be stored in a one-dimensional array. Right now, have we done arrays?
Yes, sir.
What?
Yes, sir, we have done.
I didn't get you. First of all, let me see whether you are awake or not, right? Amar, are you there?
Yes, sir.
Mahatma, Naila,
Yes, sir.
this is Mida, Mida,
Yes.
Rushda,
Yes, sir.
Shuhagi,
Yes, sir.
Tarul, who's texting? Tiloshana.
Yes, sir.
Okay, right, great. So arrays are not there in this term, right? No, it's in the second term. But I think I have given you the concept of arrays. Arrays is a data structure with multiple values like this, and we use square brackets for arrays. And arrays, we access the values using an index, and the index will always start with 0. So this is the 0th index, 1, 2, 3. We have 4 values, but the index goes from 0 to 3. 0, 1, 2, 3. And the array will have a single identifier or a name. Just array forms and then several values. And they have indexes starting from 0. Okay, what happens here? So these are the values that they have defined, predefined. Receive form from string. You ask the user to enter the form. Here form means the class. Set valid to false. Set index to 0. Why? Because we need to access individual values here. So the index is starting with 0. Set length to length of array forms. Length of array forms. Okay. Shuhagi, can you tell me what is the length of the array forms? Array forms is the array. What is the length of this array? Shuhagi. Set length to length of array forms. What is the length of this array?
So 3.
Not 3. Length of array means how many values are there? 4, right? 1,
Okay.
2, 3, 4. There are 4 values. But the index will go from 0 to 3. I will finish it at 11. Nah? So stay. So the length of this array is 4. But the index goes from 0, 1, 2, 3. Keep that in mind. That's all. Right? So what's happening here? Set length to length of array forms. That's going to be 4. Index will start from 0. While as long as validity is false, and index is less than the length. So index is 0 at the beginning, length is 4. Less than 4. When we say less than 4, what is the maximum value it goes to? When it is less than 4? Naila, what is the maximum value? When it is less than 4, what is the maximum value? Yeah?
So what's the question?
When it is less than 4, what is the maximum value it goes to?
Hmm?
Huh?
So it is 3.
Yeah, 3. Yeah, good. It's 3 because it's not equal, right? It's not equal to 4. So it goes to 3. That's correct. Why? We want it to start from 0 and go up to 3 because the index goes from 0 to 3. So this statement is correct. As long as validity equals false and index is less than 4. Less than 4 means it goes only up to 3. What do? If form is what user enters, equals array forms index. This is how we access an array element. We need the name of the array, and inside the square brackets we need to have the index, right? Like if you put 0 here, that will access the first form. If I put 3 here, it will access this one. Simple, right? Now, since we want to access each and every element, we put this index, which will go from 0 to less than 4, which is 3. Okay, so in the first loop, array forms index will be array forms 0. Array form 0 means this one. So that is checked against what we enter. If both are the same, we set the value to true. If the valid is true, what will happen? One of the while conditions, see the condition. Now you have to put the logic knowledge here. It's AND operator. If it is AND operator, both these conditions have to be true. If one is false, it will exit the loop. So if the form that we enter and the one that we have in the array is the same, we set the value to true. When the value is true, this condition gets false. When one condition is false, because of AND, it will exit the while loop. Simple. Okay. So whether we have found our form that we enter or not, we have to increase the index by 1. Why? In the first loop, index will be 0. In the second loop, index should be 1. So that we are checking this. In the third loop, index should be 2. That's why we need to have this. We need to increase the index by 1. Okay. And in the next loop, index will be 3. Right. And this loop will go only index up to 3. Right. At one moment, the index will be 3. It goes and checks. Right. Index is 3. Less than 4. 3 is less than 4. It's true. So it will check the last value. And then here, the index will become 4. It goes there and